Hi everyone, welcome back once more to one more session of discussion about motion. So in the previous chapters, we have already discussed about uniform and non-uniform motion, speed, velocity, and in this particular session, we will talk about a new topic, that is rate of change of velocity, which is also called as acceleration. Before we go for the actual discussion of acceleration, let us discuss about change of velocity and why do we need to discuss this point. So let us discuss about the first case, that is if the body is undergoing uniform motion. So if the body is undergoing uniform motion, then it will be always traveling in a straight line or in a single direction. And if it is traveling with constant speed, in that case, we can say the velocity remains constant with time, because velocity changes either when direction changes or when the magnitude changes. If both are same, in that case, the velocity remains constant. So let us consider a straight path, and on that let us consider a vehicle moving with constant speed. So the speed is not changing, neither speed nor direction. In that case, we can say that the velocity has not changed. So if the initial velocity, let me take an instance of 72 meter per second, then the final velocity is also 72 meter per second. In that case, if I check the change in the velocity of the body, let us try to subtract initial velocity from final velocity. That is how we find out change in any physical quantity, right? If you want to find out the change between A and B, what is the difference? We will find out A minus B or B minus A. Similarly, if I want to find out the difference between the final velocity and initial velocity, we will subtract initial velocity from final velocity. Then we come to know that both are same. So 72 minus 72, and that's going to be 0. So we can say that the change of velocity in this case, especially when the body is undergoing uniform motion, is 0. Let us consider second case. If the body is undergoing non-uniform motion, then what happens? So imagine the same van, okay, this time undergoing non-uniform motion. In that case, let us consider the initial velocity as a different number, maybe 36 meter per second this time, and final velocity another different number, that is maybe 72 meter per second. In that case, if we try to find out the change of velocity, that will be again subtraction of initial velocity from final velocity, and that is going to be 72 minus 36, which is 36 meter per second. Did we get 0 this time? No, the change is not 0. That is a non-zero number we are getting. When do we get a non-zero number? When the object undergoes non-uniform motion. So if that is the case, let us talk about how to measure these changes. To understand this change of velocity, we need to introduce a new physical quantity, and that will help us to answer the question, what is change of velocity of an object with respect to time? We will call this quantity as acceleration. So the definition of acceleration says it is a measure of the change in the velocity of an object per unit time. I want you to concentrate on these words. Acceleration is a measure. So first of all, it is a physical quantity which helps us to measure of the change in velocity. So as we told, see, the discussion was about the change in velocity, right? Change in velocity. So we needed a new physical quantity to discuss the change in velocity. So now acceleration is a measure of the change in velocity of an object per unit time. See, whenever definitions like these are given, we need to memorize them and we need to repeat them in our papers. So at that time, we cannot explain them when they ask the definition. You have to learn them by heart or you have to memorize them. So how do you do that? First, understand the topic so you can memorize better. See, acceleration, what is that? It is a measure. Okay, it is a physical quantity which is a measure. Okay, and about what? Of the change in velocity. That is how we started the discussion, right? Of what? Velocity of what? Of any body or of an object, right? but always with respect to time. So we divide it by time. So we get per unit time. When do we get per unit time? Always whenever we divide by time, we get per unit time. There are the same thing can be put in other words. That is, acceleration is the rate of change in the velocity of an object. See, in some of the previous videos, we have already discussed about the word called rate. Remember that? I told you the word rate is nothing but per unit time. In physics, whenever you see per unit time, we replace it with rate. So remaining same, that is acceleration is a measure of change in velocity of an object is same. This per unit time goes and becomes rate. So what is acceleration? In other words, acceleration is the rate of change in velocity of an object. Rate of change in velocity of an object. We can by heart any one of them and both are same. So now you know the definition of acceleration. Let us try to analyze it. So what can we write acceleration also as? In numerical form, it is rate. Rate means anything divided by time taken. So what is divided by this time taken? Whatever is in front of rate of. Always search for these words in front of rate of. So in front of rate of, we have change in velocity of an object. Let me highlight that. In front of rate of, what do we have? We have rate of change in the velocity of an object, right? In that case, we can say acceleration is equal to change in velocity divided by time taken. Change in velocity, or you can add of an object if you want. Just for the sake of memorization, we are not writing that of an object. Change in velocity divided by time taken. So I hope that is clear. Acceleration, what is acceleration? It is the change in velocity by time taken, or we can say rate of change in velocity. What is change in velocity? Change in velocity can be also called as final velocity minus initial velocity. So the same thing, change in velocity, we write it as final velocity minus initial velocity divided by time taken. So if we give some symbols for these, we can write it in short form as acceleration replaced with small a, final velocity replaced with small v, initial velocity replaced with small u, time taken with small t. I mean, all this small t, small v, small u, small a, when I say, it is not the letters written very small. It is about the lower case I am talking about, okay? Lower case. So, a is equal to v minus u by t. What is v minus u? Change in velocity divided by time. So, this is an important formula we will be using in all the equations of motion in your future classes. You better concentrate on this little more. Now let us see how we can apply this formula that we learned just now. Acceleration is equal to change in velocity by time taken. First, the units. Let us try to derive the units from what we already know. You know the numerator is change in velocity. So both the units are same. Change in velocity is actually same kind of physical quantity, final and initial. So their unit will be meter per second in the numerator. And in the denominator we have time taken. Time taken, its SI unit is seconds. So what do we have here? Change in velocity is in meter per second divided by time taken is in seconds. Mathematically, if we simplify, the numerator remains meter per second. The denominator seconds, when it comes up and becomes multiplied by, it is written as 1 by seconds, or it becomes a reciprocal. In division of fractions, we know that when two fractions are written as one divided by the other, the denominator becomes a reciprocal and gets multiplied, right? So second becomes into 1 by second. If we simplify this further, m into 1 is m, second into second is second square. So the final answer will be meter per second square, which is also written as ms to the power minus 2, but read as meter per second square. This is the SI unit of acceleration. Let us try to recall all the SI units of the physical quantities we learned. Distance traveled or displacement is always measured in meters. Speed and velocity are measured in meter per second, or ms to the power minus 1. Acceleration is measured in, it is right in front of you, meter per second square. So let us discuss about two types of acceleration that we will discuss further. First is positive acceleration. What do you mean by positive acceleration? See, acceleration means change in velocity, right? What do you mean by positive? Say, if the acceleration takes place in the direction of velocity, we call it positive. If it takes place in the direction. Some of us may get confused. What do you mean by direction of velocity? In other words, the same thing is called as the acceleration is positive if the velocity of the body is increasing. Means final velocity should be greater than initial velocity. An example of if the initial velocity, in this case, see, if initial velocity is 2 meter per second and final velocity is 8 meter per second, see that final velocity is more, right? And time taken is 2 seconds. Then acceleration is given by, let us calculate using the previous formula. What is the formula? A is equal to v minus u by t. What is v there? Final velocity minus u. What is u? U is initial velocity. So final velocity minus initial velocity divided by. See, we have already said rate. Rate means what? Divided by time. So let us put the values. What is v? V is 8. That is final velocity. Minus initial velocity is 2. 8 minus 2 divided by the time taken, which is 2 seconds. So divided by 2. 8 minus 2 is 6. So the numerator becomes 6 divided by 2. Simplification is 3. But the SI unit, you should remember, acceleration is always this A we are finding out. So its acceleration SI unit is meter per second square. So this is positive acceleration, right? Now let us talk about negative acceleration. What do you mean by negative acceleration? See, if the acceleration is taking place opposite to the direction of velocity, in that case we say the acceleration is negative. Or in other words, it means that the velocity of a body is decreasing, then we call it as negative acceleration. Say, for example, when you start applying brakes, what happens to the vehicle? It starts to slow down. When you press the accelerator, it starts to speed up. So in the initial case, when we said about positive acceleration, we are talking about pressing the accelerator, right? And now, when you're talking about negative acceleration, which part is called as a negative accelerator? The brakes, of course. When you apply the brakes, the vehicle slows down. This is called as negative acceleration. Or you can say that initial velocity is higher than the final velocity. So let us take an example and find out the values. So if the initial velocity is 10, see, initial velocity is bigger and final velocity is 4. So final velocity has slowed down. The vehicle is slowing down. And the time taken is 3 seconds. Then the acceleration is given by, you know the formula already. A is equal to v minus u by t, right? Put the values. What is v? V is the final velocity. Which is the final velocity? 4. So it is 4 minus u. What is u? U is initial 10. So it is 4 minus 10 divided by time. What is the time taken? Time taken is 3 seconds. Therefore divided by 3. What is 4 minus 10? The difference is 6, but bigger number sign is minus. So the answer is minus 6 by 3, which is equal to minus 3 meter per second square, right? So I hope you understood. Whenever the initial velocity is greater and final velocity is lesser, means the body is slowing down, means the acceleration is negative. This is also called as retardation or deceleration. But there is an argument about this, that many people consider negative acceleration and retardation as two different topics. But popular belief is that they are just two different words, but the meaning is same. When the body starts slowing down, we call it as retardation or deceleration or negative acceleration. If the body speeds up, we call it as positive acceleration. Let us. So a new discussion again on acceleration is uniform acceleration. What is uniform acceleration? If you consider a body moving in a straight line and its velocity is going on increasing or decreasing in equal amounts in equal intervals of time, then we say the acceleration of the object is uniform. See, it is not uniform motion. Let me be clear. This is non-uniform motion because velocity is changing. But the change of velocity in the given time is constant. See, for example, the motion of a freely falling body is called example for a uniformly accelerated motion. Let us consider a fruit falling from a tree. In that case, say acceleration due to gravity is 9.8 meter per second square. We will discuss that later in the chapter. But right now, I just wanted to give you a number just for imagination. That's why I told that number. Or let us try to understand it without the numbers also. Imagine a body is falling with a velocity of x. Okay. And after some time, it falls with a velocity of y. We try to find out the difference of y minus x divided by the time interval t. After some time, if the body again reaches a new distance in again the same interval t, first it was t, now again another t seconds, the body moves further, but velocity has increased to z. Now I have two different velocities, y and z. I subtract them also. So z minus y divided by the same interval again. The earlier interval was t, now also it is t. So what do we get? Z minus y by t. If both of the answers are same, that means the acceleration is same. If we want, we can just consider some numbers. See, imagine the first velocity is 3, the next velocity is 5 in 2 seconds. So what is the difference between 5 and 3? That is 2 divided by time taken 2. So 2 by 2, answer is 1, correct? So 1 is the acceleration. Now imagine after that attains 5 meter per second velocity, if further again 2 seconds passed and the object has speeded up to 7 meter per second velocity. Now which is the final velocity? 7 meter per second. Which is the initial velocity? 5 meter per second. Subtract 7 and 5, we get 2 divided by the time, that is again 2. So 2 by 2, answer is again 1 meter per second square. So the acceleration remains same in the given intervals of time. Such movement or motion is considered to be having uniform acceleration but not uniform motion. Remember, the velocity is going on changing, but the change is constant, right? So let's talk about the opposite. What is opposite? Non-uniform acceleration. This is when the body has covered different change in velocity, okay, in the same intervals of time. If the amount of difference of the velocities is unequal in the equal intervals of time, then we say the object is moving with non-uniform acceleration. Obviously, this is non-uniform motion. Further, it is non-uniform acceleration. Consider a car. First, it moves with a for certain speed. It goes on increasing. Then suddenly, it moves very fast. Then it moves slow. So, what is about the changes? Initially, the acceleration was low. Then suddenly, it had a high acceleration. Then at last, it had negative acceleration because the car started slowing down. I would like to repeat here. Please see, in the first, the car started from rest and started to moving fast. Means there was a small acceleration. In the middle of the journey, the car started to speed up very fast. Means the acceleration increased. So it is a higher acceleration. Then the car slowed down to a stop. Means the car is having negative acceleration. Try to remember the other two words for negative acceleration. That is retardation or deceleration. So this leads it to stop. Now we have all three types of acceleration in the same given intervals of time. This is an example for non-uniform acceleration.